Morning, guys. So I just wanted to post a video explaining the answers. I know people had confusion. I'm guessing we're going to have a lot of the same questions. So this is the point in time where I would stop everyone doing work and then just go over the problems to let you guys know the explanation. Pretty simple explanation, but it definitely gets lost in the text and the translation. So with the first one, we wanted to know the probability of one or more of the 7 cars flashing their lights to warn oncoming traffic. So if I wanted one or more, that means 1 or 2 or 3 or 4 or 5, 6, 7. Now, the calculator, for some reason, with this 84, can't do that. It can only count down. So if I wanted less than 5, it could do 5, 4, 3, 2, 1, 0, but it can't count up. The Inspires can do it. So if we had Inspires, this would be a lot easier. Unfortunately, the 84s, we have to do this step. So again, if I wanted 1 to 7, that means I don't want 0. I want any other number of successes, I just don't want 0. So what I did is I calculated the probability of finding 0 successes, so no cars flashing their lights, and I subtracted that probability from 100%. So therefore, there is a 97.2% chance that 1 or 2 or 3 or up to 7 cars will flash their lights at oncoming traffic. That then means that about 2.8% of the cars, there's a 2.8% chance that 0 of the cars will flash their lights. Now, the second question I posed is, what is the expected number of cars? Given that 40% of the sample size should flash their lights, 40% of the sample size is 7 times 0.4, so that gives me 2.8. So we should expect about 2.8 cars to flash their lights. And so then part C was asking, well, what's the probability of the highest expected outcome to occur? So this would be the highest probability of between 0 and 7, and I got an error. And the error is because you can't have 2.8 successes. The calculator is programmed to know that it has to be an integer. So it has to be a whole number, 0 through infinity. So I rounded that 2.8 up to 3, and I did binomial PDF because I want exactly that many successes. So of the 7 cars, there's a 40% chance of success, 3 successes. That's about a 29% chance of success. And then the last one was the standard deviation, which we'll be getting more into, especially when we get to the normal distribution. You'll see in the calendar I posted that I have 2 weeks of the normal distribution because I think that that should have the strongest emphasis, and it kind of wraps things together. There's obviously more beyond the normal distribution, but we're simply not going to get to it. So the standard deviation of this problem would be the square root of 7 times 40% times the probability of failure, which was 60%. I'm getting 1.296 cars. So those were my answers. I'll post this in the classroom. I also want to talk a little bit about grading. Nothing is decided yet. Something that was being thrown around, I guess the school board kicked back the pass/no grade option. And so what might happen is you guys might have a choice, either pass/fail. So if you don't like your grade, you can take the pass. If you didn't do anything, then you fail. Or you might be able to choose to have the option of having a letter grade. So let's say you're standing at an A and you want that A instead of a P for pass, you might be able to get that. I do not know if that's going to come to fruition or not, but I just want to let you guys know that if it does come to that I got you. You have nothing to worry about, and I will look out for your best interests. Posted today. Today's off. Nice weather outside. Get outside. Breathe some nice air. We're going to have some rain tomorrow. Saturday is going to be gorgeous, and then all next week is going to be rain. So get outside. Look out for your mental health. Check out your student notices if you want to take a look at Spirit Week. I miss you guys. Hope you're hanging in there. I will talk to you later.